Hello. Today we're going to be solving quadratic inequalities algebraically. So we're going to start off by reviewing the two different inequalities that we've done the past couple of days. So looking at this one, we're going to graph the following using completing the square. We're going to notice it is an inequality, which means our graph is going to be shaded and it will be a dotted line. So we're going to group our x squared and our x term together. We're going to go ahead and factor out the a value, which gives us x squared minus, and then careful because if we are taking 1 and dividing out 1/2, it's the same thing as multiplying by the reciprocal. So it's x squared minus 2x. And then we're going to write plus blank, and then afterwards we write minus blank. Our a value is negative 1/2, so our a value goes on that minus blank. And we do b divided by 2 squared to figure out what that c value is. So we would get y is greater than negative 1/2 of x minus 1 squared plus 1/2, which means my vertex is right 1 and up 1/2. My stretch is negative 1/2, so I'm going to go over 1, down 1/2, over 1, down 3/2, over 1, down 5/2, and we can even make it over 1, down 7/2 on here. So those are the points for our graph. This would be a dotted line, and we do also have to shade. So we're going to go ahead and test a point. We can test anything that's not on our graph. So we cannot test 0, 0. I'm going to go for 0, 1 instead. So y is 1, x is 0, and I just plugged it into my original equation. And you get a true statement, which means 0, 1 should be part of the shaded region. So we're going to shade outside the parabola. Okay, number 2 is a different type of inequalities. You notice it has a 0 here instead of a y value. So we're looking for our graph. On our graph, we're looking for where our values here are less than 0. Okay, so right now, first, let's go ahead and graph it. Right 1, down 7. Our stretch is 4, so we go over 1, up 4. Over 1, up 12. And then we're off our graph grid already. So this is our graph. So to find where our graph here is smaller than 0, we're looking for where our graph is below the x-axis. And so if we were to look at everything below the x-axis, we can see that on our graph it would be this chunk down here, the bottom part of our parabola. So we need to know our zeros. Since it doesn't say no calculator, we can go ahead and type these in and get these answers via the calculator. So our zeros here, if you hit second, calculate your zero, should be negative 0.32, comma 0, and 2.32, comma 0. And so we want everything in between those x values. So we're going to do negative 0.32. Oh, nope, it's a bracket because it is including it. So less than or equal to, and then 2.32 with a bracket. So today what we're going to do is we're going to solve the same inequalities, but we're going to do it algebraically, and we're going to do it with no calculator. We want exact answers, so answers that have square roots in them and fractions and things like that. So our first step here is going to be to pretend it's an equal sign, and we're going to solve this by finding the zeros. Okay, so factor if you can. This first one factors nicely. The zeros are going to be at x equals 0 and x equals negative 2. Once we find our zeros, we're going to plop those on our number line. Probably go least to greatest. That's how number lines work. There we go. Negative 2 and 0. You are going to look at your inequality to determine if it's an open circle or a closed circle. So these are closed circles. And then what we're going to do is we're going to test each interval. And that's going to help tell us if our intervals are going to be greater than 0 or less than 0 for our y values. So for instance, we can go ahead and plug negative 3 in for x, and we can figure out what that would be. So we would get, if we test -3, we get 45 minus 30 is greater than or equal to 0. This is a true statement. If we test -1, for instance, we would get 5 minus 10 is greater than or equal to 0. This is not true. And then if we were to test, for instance, a +1, we would get 5 plus 10 is greater than or equal to 0. This is true. So the intervals that are true would yield our solutions. So it'd be everything over here and over there, not in between. And you can always back this up by visualizing, since our a value is positive, our quadratic would open up. And so we're looking for everything above, which would be the same two intervals that we have there. So then we can pull our interval off of our number line, and that would be our solution. So that's the process. Find zeros, test the different intervals, and then answer the inequality. So let's take a look at this next one here. We have 2x squared minus 2x minus 5. This one, if I go ahead and try to factor it, it's not going to end up working. I can't put the 5 there, I can't put the 5 there, and still get 2 back out. So unfortunately, factoring does not work. We have to go to our quadratic formula. So we are going to actually do this by hand because we still want exact answers, and this would be on a no calculator portion. So we're going to do x equals -b plus or minus the square root of b squared minus 4ac all over 2a. And we're going to simplify. So we have 4 plus 40, which gives us 44. So we get 2 plus and minus 2 root 11 over 4. And we are going to divide up our answers. So it's 1/2 plus and minus root 11 over 2. So on your number line, you have to be careful with which ones go where. The 1/2 minus root 11 over 2 has to be smaller than the 1/2 plus root 11 over 2. On here, you're going to have open circles because your original inequality did not have the or equal to. And then we're going to test each interval. So if we test a really negative value here, let's go ahead, I don't know, maybe -100. Imagine plugging in -100, you're going to end up with a rather large number. So you're going to get 0 is bigger than some large number. And that is not true. So this is not going to be part of our solution. In between here, you're going to test 0 or something like that. You're going to get 0 is bigger than -5. That is true, so that part works. And lastly, you can pick another large number like +100. If you plug in 100, you're going to end up squaring, again, some large number, multiplying it by 2. You're going to get 0 is bigger than some other large number. This is not true, so therefore this can't be shaded. Visually, this graph also opens up, so you can visualize this is what our parabola would look like. And we want the numbers that are less than 0, so where it's below, so that backs it up. Which means in interval notation, we would have 1/2 minus root 11 over 2 and 1/2 plus root 11 over 2. Okay, let's go ahead and try a couple more here. So we have this next one. So we do want to go ahead and solve this. This is factorable. This is x minus 4 squared is less than 0. So our zeros occur when x is 4. At 4, you're going to have an open circle. So we have two different intervals to test. So we can imagine plugging in 0. We get 16 is less than 0. That is not true. You can imagine plugging in 5. We get 25 minus 40 plus 16. That would give us 1 is less than 0. This is not true either. So we're looking for where this graph is less than 0. This just doesn't happen. So nothing works. Even 4 doesn't work. It's an open circle. When that happens, we just say that there is no solution. And this is because our vertex is at 4, 0. If we factored it, it's actually in vertex form right now based off of the way it looks. And so our graph doesn't go below the x-axis. You can imagine how this inequality might change if it had been x squared minus 8x plus 16 is greater than 0. We would have a different answer. It would be from negative infinity to 4 and 4 to positive infinity. And imagine changing it a little bit further even. Let's say we said it was greater than or equal to 0. That means everything above works, but so does everything above 0 works, but so does 4. So that would be the entire parabola working. So all depending on what the inequality looks like, your answers get drastically different for that one. Let's go ahead and try one more here. Looking at this one, we're going to try factoring to see if it works. So negative 2x could be our first term. We're going to have a 3. Let's see if that one works. And it should if it is x minus 1 and minus 3, because that gives us a positive 2x. Yep, that works out. So our two answers then would be negative 3/2 and positive 1. So we would put those on our number line. These ones would be filled in circles. We can go ahead and test each interval. So for instance, if we plugged in, I don't know, negative 2. If we plugged in negative 2, we would get negative 8 when we plugged it in, plus 2 plus 3. So we would get 0 is greater than or equal to negative 3. This is true, so this chunk works. If we test 0, we get 0 is greater than or equal to 3. That does not work. And if we plug in 2, we would get 0 is greater than or equal to negative 8 minus 2 minus 3. So that would be negative 7. That works. And so this chunk here also would be shaded. Visually, this graph would open down. It's the first one where your a value is negative. So our vertex would be in between our zeros, and it would have to open down. We're looking for where our graph is below 0. So that's the lines would have to be underneath. That backs up our answer here. So it would be negative infinity to negative 3/2 in union with 1 to positive infinity. Let's go ahead and try one more problem. It's going to be an application problem based off of inequalities. So we're talking about a right triangle here. One leg of a right triangle is 7 centimeters shorter than the other leg. How long should the shorter leg be? So here's our shorter leg. If the hypotenuse is at least 13. And so looking at this, since our shorter leg is x, the other one would have to be 7 centimeters longer to ensure that the shorter one is 7 centimeters shorter. Okay? So what we want to do is we want to set up an equation. A squared plus b squared is compared to c squared. But we want the hypotenuse to be 13 centimeters or more. And so we want the legs squared to give us greater than or equal to 13, because if they're greater than, then you'd have a different right triangle, and the hypotenuse would be bigger than that. So we can go ahead and solve this inequality. X squared plus 14x plus 49 is greater than or equal to 169. And then we're going to go ahead and get everything to one side. So 2x squared plus 14x minus 120 is greater than or equal to 0. You can factor out the 2. And then you can continue to factor to get 2x 12 and x minus 5 is greater than or equal to 0, which means your zeros are negative 12 and 5, which makes sense because it would be a 5, 12, 13 right triangle. So you put everything on a number line. It'd be filled in because of the or equal to. And with this one, you have to be careful because in this context, anything less than 0 actually is not going to work because it would not be real. We can't have negative side lengths. So we really want to test from 0 to 5 and from 5 on up. If you plug in 1 into your inequality over here, you would get a negative number is bigger than 0. That does not work. If you plug in a number bigger than 5, like 100, you'd get a large number is greater than 0. This is true. So everything from 5 to infinity should work. So it should be any number greater than 5. Thank you very much for listening. I hope this helped.